Hello, my name is Manoske, and I'm the Principal Product Manager for Cryptography and Security Products here at HashiCorp. Today, I'm excited to talk to you about Vault Enterprise combined with YugaByte Cloud, protecting data wherever it lives across the globe against multi-regional failover, as well as situations of high performance. A little about me. I joined HashiCorp around 5 years ago to focus principally on the creation of security products. First on the creation of Vault Enterprise, and later on with the process that ultimately became HashiCorp Boundary. I've spent most of my time in and around security and cryptography, having spent stints focused on defense systems as well as encryption at NetApp, as well as both building it and investing in security next generation infrastructure solutions and threat intelligence solutions at Alien Vault, which later became AT&T Cybersecurity, as well as venture capital firms such as GGB Capital. And my focus and background as an education perspective is on cryptography and as well as like constituent sciences and mathematics that are related to it, namely economics, quantitative economics, and game theory. About HashiCorp, though, because I think one of the most important things here is the really exciting alignment that exists between HashiCorp and YugaByte. HashiCorp was built in 2012 and founded by Mitchell Hashimoto and Armin Dadgar, principally to build software to really respond to a lot of the exciting challenges that are coming as the world enters a very interesting transition infrastructure, a movement from a static infrastructure, a world where we have very clearly defined boundaries for principles for networking, computing, identity, and deploying and running applications, to a world of dynamic infrastructure, a world where there may not be one single cloud environment, but multiple cloud environments, a world where there may not be one style of computing environment, but multiple styles of computing environment, like containers, like infrastructure, like serverless, etc. And all of the products that we host here at HashiCorp, these are just a selection of them, are really focused around this transition of moving from a static world of really clearly defined infrastructure to a world where infrastructure components are going to change, where I would rather focus on how do I build long-lasting workflows that can be defined, but those workflows can be really quickly and readily applied to just different types of infrastructure as my needs change, as technology changes, etc. Now, all of the primary products at HashiCorp focus on this transition from static to dynamic infrastructure. And in particular, the one that we're going to talk about today, Vault, really focuses on what happens from a security perspective when you move from static infrastructure to dynamic infrastructure. Static infrastructure really focuses on that clear definition point. It's not just simply on-prem or specifically one type of cloud environment. It's really about what happens when I focus on, a particular style of infrastructure where everything is very clearly defined and changes to that infrastructure are, acceptably inflexible. Well, from a security perspective, a lot of stuff happens on that, when you adopt that kind of style of infrastructure and need to move to a more flexible style of infrastructure. But one of the biggest, and one of the ones that we focus on the most across all of our security products here at HashiCorp, is what happens to identity. In a statically infrastructure world, IP-based identity or other types of very static, clearly defined pieces of identity persist and make a lot of sense, right? If I'm existing completely on-prem, I can identify a system based off of its IP address, because if I need to move it, I can just change its IP address, or I can change it within the ledger of how I identify that system's. If I move a 1U rack from one, system to another part of my data center, another aisle, or I move from one VM in my cloud environment to another, I can, use whatever statically defined networking based frequently identity that earmarks a specific workflow to another one, because I'm controlling everything. In a dynamic world, I'm not controlling that much, or rather, I'm not controlling as much as I would like, possibly. I live in a world where there are lots of different types of applications, lots of different types of infrastructure, constantly changing principles for those infrastructure, and ultimately, I live in a world where there's a little bit more low trust identity. And what we mean by that is that, in the world of static identity, there's clear definitions around what the perimeter is. In a dynamic world, there may be, less clear or even minimal, definitions of what the perimeter is, particularly to span a bunch of different clouds. Now, there's definitely security concerns within this concept. If I have an environment where I'm moving to multiple different types of cloud infrastructures, I might be in a situation where, I need to think really seriously about what my security model is, over the wire, as well as what communicating with them. And that's certainly important. But, when we talk about this move from static to dynamic, and the change that happens within identity, it's not just a security concern, it's a complexity concern, it's an organizational complexity concern. And this is a really good example of that. The movement from a dedicated or static world to a world where I integrate with common cloud hosting providers is one where I'm inherently having to link my identity system to a variety of different types of identity systems. It's not just moving from on-prem to one cloud environment. What happens when I want to take on workloads in a different cloud environment? What happens when I want to take on workloads in a container environment where the limitations of a certain cloud provider's style of identity may have different implications on me describing logically access control rights within the same workflow in another cloud. So this, presents the real interesting challenge from a security perspective, that it's not just about stopping hackers. The goal of trying to tailor solutions to a world of dynamic identity, where identity can take multiple forms of attestation, but ultimately links back to a cohesively defined, well-formed workflow and a well-formed logical entity, is one that ultimately all of our products at HashiCorp focus on from a security point of view. But in the specific case of Vault, it's one that Vault has spent a lot of time focusing on, trying to understand sort of what rights users or applications have to accessing secrets, and ultimately taking away the heavy lifting of building a secure infrastructure for protecting data at rest and in flight. So Vault and Vault Enterprise are solutions that are built to serve as a software orchestration platform. What we mean by that is that this is a solution that takes away a lot of the challenging elements of protecting data at rest and in flight. There are a few challenging elements here. The first one we already talked about, which is identity. How do I span identity across multiple different types of services, cloud providers, AD LDAP environments, containerized environments, basically anything that you could possibly think of, and especially the things that we can't think of yet. Well, Vault takes care of that through an interface that we call unified identity, that allows you to be able to define a workflow and the entities that exist to communicate with that workflow, users or applications, in such a way that moving from one identity provider to another doesn't disrupt that workflow. It's simply about relinking whatever the aliases that could be generated as attestations of that identity from one cloud provider or one AD or LDAP interface or one type of style of IDP you would like to another, is a transparent process. So that process is really part of the importance of why Vault has been grown to a significant amount of popularity. The other one is the fact that when we want to protect data at rest and in flight, we typically use encryption. And the challenge with encryption is that encryption is very complicated to deploy. It's complicated for two reasons. One, the selection of algorithm can be very complicated. What is a good encryption algorithm? How do I implement that encryption algorithm in a safe way, et cetera, et cetera? The other one is key management. How do I store those keys? How do I protect that information? One of the exciting parts about Vault is that unless you want to, you never touch an encryption key. The processes in which you do need to encode data or protect data, unless I want to have a manual part in that process, so we'll talk about one of those situations where I might want to actually control a little bit of that information. I don't ever need to touch that data. I can just, if I just want to store a blanket secret within Vault, Vault takes care of encrypting that data, like storing it at rest, making sure that it's very, very, very difficult for an adversary to, breach Vault and steal that secret. And ultimately, all the use cases around Vault are about allowing applications and users to be able to seamlessly access things like secrets management. How do I store and protect access to data without having to worry about the complexities around, different types of identity providers and solutions and rewriting ACL every time, or encrypting the data at rest or in flight. Data encryption. If I do want to have situations where I, handle key lifecycle management or other types of encryption processes, how do I remove as much as possible the onerous elements of deploying cryptographic infrastructure, protecting those keys at rest, in flight, et cetera? And then again, linking back to those identity systems. This is at the end of the day an identity problem frequently. And finally, like advanced data protection as a whole. How do I think about things like protecting secrets that won't live within Vault's cryptographic barrier, or like be necessarily protected fully by Vault at rest, that need to live in an external service? How do I protect key lifecycle management workflows that live completely outside of Vault? How do I look at managing credential workflows in such a way that an adversary steals that credential, they don't gain like undue access to your infrastructure? These are all common models for using Vault and Vault Enterprise. And the consequence of this over the course of the roughly 5 to 6 year lifespan of Vault has been that we now have situations where Vault, and especially Vault Enterprise, are very much embedded within the financial system, governments, large organizations, et cetera. I mean, today we have Vault Enterprise users who are using Vault to process over 2 trillion transactions of secrets management data encryption workflows per year. People download Vault open source, well north of 1 million times a month. And we have right now hundreds of enterprise customers. So, the growth of Vault and Vault Enterprise can really be well tied to the fact that these challenges around, moving from static to dynamic identity, trying to protect data at rest and in flight with strong cryptography, but doing so in a way that doesn't require you to have like a bachelor's of computer science specifically in cryptography or more. These are really big problems. And these are problems that are felt by a lot of organizations, a lot of teams, and a lot of people across the world. So we're very excited about the evolution of Vault, as well as some of the evolution of use cases. And today we're going to drill specifically into a use case that dovetails very well with YugaByte Cloud, which is the advanced data protection features within Vault Enterprise. So what happens when those secrets live outside of Vault? So we talked a little bit about a situation where, Vault protects all of its secrets at rest, handles the encryption in flight, but sometimes I don't want to have the secrets that I'm protecting within Vault necessarily live within Vault. And there's a few different reasons why, whether the secrets are like credit card numbers, social security numbers, tax ID numbers, etc. Sometimes I may want those secrets to live outside of Vault in a place such as a database or a file system. And, those reasons why could include that the data is very, very large, like a very large scope of data. It's a data lake. Vault is not an ideal place to store all this data. The application or system performance, I might want it to be closer to the applications that are going to request access to this large amount of data. It's, better communicated to that application via some bespoke protocol that application or the database or file system, the end target system, et cetera, is using, or because like I'd like to have Vault deployed on different styles of systems and configurations than whatever is like the data storage location for this kind of sensitive set of secrets. There's also legacy code or system functionality, and I think this one's really important. We frequently in infrastructure talk a lot about how exciting things can be with adopting new technology. What we do not talk about enough of is how difficult it can be to refactor code or deal with legacy systems in such a way that we adopt new technology but don't have to go reinvent the wheel for everything. Especially for situations where there's large amounts of PII, there may be legacy systems that are better suited and tailored towards specific APIs for applications to communicate with. It just doesn't make sense to move those all into Vault. That could, otherwise invalidate or break your existing system architecture. And I would still like to be able to have the data protected by Vault. But overall, for these reasons and many others, I need to have them live in a place that's outside Vault's traditional cryptographic barrier. The Transform Secret Engine, which is a feature within the ADP module for Vault Enterprise, allows us to do this. And basically what it allows us to do is it allows a user application who is trusted to create encoded data that will live outside of Vault. And the place that it will typically live outside of is like a database or a file system, pretty much anywhere you want to store that data, because we don't necessarily trust that data. And that data is protected in such a way that if an adversary were to be able to breach that untrusted or semi-trusted container, exfiltrate all the contents of that container, they don't get access to the underlying data there because the data there is encoded. Now, what's interesting about this is we've talked a lot about encryption here, and I've specifically said something that's a little bit different than encrypt. I said encode. The reason why I said encode is that the Transform Secret Engine allows you to choose, pursuant to whatever your compliance requirements, security requirements, which format to be able to protect that data. Would I like to protect that data, for example, via masking? I would like to just obfuscate all that data. It's not necessarily super sensitive, but it's stuff that I just don't want to be visible. We can do that. And you can create the format in which it allows you to do that with the Transform Secret Engine. Let's say that I do want to encrypt that data. I want to be able to protect it in such a way that it uses strong encryption, but I want it to be format preserving. And I just say, Vault, I would like you to take care of this process for me, encode it for me, and then I can take it and put it in a database, for example, and put it in such a way that it doesn't disrupt the schema of that database. It looks like a credit card, for example, but it isn't a credit card number. It's actually encrypted. That's okay too. Vault, the Transform Secret Engine within Vault allows you to be able to do this via the AES FF3-1 algorithm in format preserving encryption. And this is pursuant to the NIST SP 800-36 Gulf standard. So this is, this is very well trusted and well formed cryptography to be able to do this. But what happens if I don't want to use cryptography at all? And there are a few different reasons why you might want to use this. You might have, for example, a PCI DSS auditor that is looking at credit card stripe data and has concerns about using cryptography as a whole, just because cryptography is, relies upon mathematical intractability, which is to say the difficulty of computing power to be able to compute a result or search for an answer. Sometimes, as we've seen in the past and are seeing currently with quantum computing, there may be times where that computational or mathematical intractability may not adequately protect protect certain types of data. Computing gets more powerful, it gets easier to break certain types of encryption. Well, we have a format within the transform secret engine to use tokenization that allows you to be able to create completely non-reversible identifiers for that data. So it will live in an external service, an external place, just like FPE. It will persist in such a way that if an adversary were to breach that untrusted or semi-trusted environment, that they only get access to encoded information that's non-reversible. But in this case, it's truly non-reversible because it doesn't use cryptography at all. It uses a completely separate method, and that method allows this data to be protected with perfect forward secrecy. So as computing power gets better, it doesn't get easier to break into this data. Okay, so where does YugaByte come in, and YugaByte DB and YugaByte Cloud? Well, when we use tokenization specifically, there are some exciting opportunities that allow us to be able to operate at scale. And like I said before, Vault Enterprise right now is operating frequently at a scale such that the world financial system is actually heavily reliant on the stability and security of certain types of Vault environments. The ability then for us to be able to encode, encrypt, or handle any kind of amount of data within Vault where we need to protect secret and sensitive information at scale needs to reflect this. And as a result, we've built tokenization to scale to a situation where we have potentially tens or hundreds of billions of tokenization mappings that are non-reversible but need to be protected. Now, you can store tokenization by default, the mappings within Vault Enterprise and its storage backend. However, we also allow you to be able to store that data in an external storage environment we call secondary storage. And this is very important because frequently I may want to do this for a number of other, application performance reasons for Vault, in this case, this being the application, because I might have another team that manages my database environment separate from the security team, et cetera. There are a lot of reasons why you might want to do this. From a Vault perspective, this is also to preserve the effectiveness and speed of Vault itself, to ensure that this process does not otherwise consume system resources that otherwise might impair elements of Vault's ability to serve as a CA or a secure secret storage point to replicate that data to dozens or hundreds of clusters across the world for Vault, et cetera. So secondary storage can be provided, in which case that secondary storage container is or database is actually fully encrypted. Vault handles all the encryption. Again, you don't need to worry about key management or anything else. You just need to point it to whatever is an applicable secondary storage environment. What's really exciting about this is that YugaByte and YugaByte Cloud specifically have created a distributed database model that allows you to be able to really adequately serve as a very resilient, very performant secondary storage target for Vault tokenization. And they do this by exposing a Postgres compatible API layer via YSQL that allows Vault Transform to, as we'll see in a moment, very seamlessly transition the encoded data to a persistent storage environment that can live outside of Vault in a YugaByte DB environment. Now, what's cool about this is that YugaByte Cloud has a variety of different types of replication features that allow you to be able to persist this data very quickly in a way that is accessible to applications locally and scale horizontally across regions. What was very cool about this is that YugaByte DB and Vault actually have very similar features in this manner. We can both create clusters that can serve as disaster replication clusters. We can both create clusters that allow us to be able to scale across large different environments and serve service requests from local applications to improve performance. And one of the exciting parts about this is that both of us are empowered by the fact that we use Raft. So Raft is a consensus algorithm for distributed computing that we use very frequently across all the HashiCorp products, including within Vault and Vault Enterprise. And this is actually the underpinnings of a lot of what YugaByte DB uses. So a lot of sort of how we think about distributed computing at HashiCorp is really well tied with how YugaByte DB works and ultimately how YugaByte thinks about distributed computing with YugaByte Cloud. And this allows us to really dovetail nicely in terms of deploying reference architectures where Vault, specifically Vault Enterprise, can scale globally across very large performant environments and service very sensitive, high performance workloads, and ensure itself that it has a secondary storage container that can keep up with it. And YugaByte Cloud is more than capable of doing this task. So let's see how easy it is to deploy a YugaByte DB as an external secondary storage target for tokenization. So our goal here again is to create a tokenization transformation method that allows us to be able to use that YugaByte cloud instance as the secondary storage target. And again, Vault will take care of all the encryption for it. If someone was to, for example, to attack and dump the contents of this database and won't give them undue access to any of the data within Vault, Vault will protect this just like it will protect itself using the its cryptographic barrier, specifically with the AES 256 and Galloy counter mode or GCM mode encryption algorithm. So first thing we do is we just enable a transform mount, and then we create within that transform mount the data to be able to tie that any kind of transformations that I would choose to have with that mount to an external storage within YugaByte Cloud. In this case, as you can see within this terminal text here, I would be deploying this in a way where I would be passing it, a set of identifiers for what would be the credentials for accessing that, as well as the cloud URL here. And this could be, an on-prem YugaByte DB instance. It could be a YugaByte cloud instance. It doesn't really matter because of YugaByte DBs presenting a Postgres front end. We can via YSQL. It allows us to very quickly be able to adapt to wherever you want to store this external secondary storage environment for tokenization. I then create a new schema to be able to store those tokenized values. And then once all this is set up, I create a new transformation using YugaByte Cloud as that end target, or YugaByte DB on-prem, whatever is kind of your choice. And this is really exciting for a number of different reasons. One is that I don't necessarily need to tokenize everything. Again, the transform secret engine is sort of like a Swiss Army knife for allowing you to choose how I'd like to encode data that's going to live outside of Vault pursuant to whatever your compliance requirements are, your security requirements, et cetera. The second thing what's exciting about this is that in Transform, I can apply a number of different type of roles, which are effectively contexts upon which I want to have a specific workflow. For example, we're going to go talk about the transforming passport data here, but I might use a passport number differently depending upon if I was trying to identify the user, if I'm using it as a proxy for some other type of like identity management system, etc. These different roles correspond to different contexts upon which different entities may use the data that's stored. So if I'm using format preserving encryption, for example, the roles would actually be the different kind of bearers of the ability to be able to decode that information. In the case of tokenization, actually, it allows us to have differentiation between how different types of applications have access to different types of tokenization mappings. So I don't have to have everything used as external storage target, but I could say that like, hey, I know that this is going to be a workflow or use case that's going to have a very large amount of data. I'm going to tie this one type of transformation and these roles specifically to using this external storage with YugaByte. And so here I'm going to explicitly do that. I know that this is going to be some kind of global ID interface. I'm going to be taking in a lot of different types of password information that I'm going to be tokenizing. So I would like to be able to have it use the Postgres store, which in this case is specifically going to be piping to YugaByte. Once we have that set up, it's fairly simple to actually begin using this process. This is something that if I'm a user or I'm an application, whether I'm commuting through the CLI, the API, or in the future the UI specifically for creating encoded values, I just create transformations that are specifically from an identity that is scoped to this role and in a type and format that is with the transformation that I just created. So when I create this new passport number, I just pass it in the same way that I would pass any type of transformation via the endpoint as well as the transformation type that I have previously set up. And what happens here is if you were to go back and look into YugaByte, you're going to start to see these values start to appear. What are these values? These values are the tokenization mappings that are necessary to be able to decode this information. Now, what you'll notice here is when I encode this value 1 through 9, I'm not seeing 1 through 9 here. Actually, what's happening is I'm encrypting as Vault these values and then storing the mappings in an encrypted format in the database in YugaByte Cloud. And that's very important. That's very important because it means, one, that you don't need to subject your database environment to the same rigorous level of security necessary that Vault does. Vault is taking care of a lot of that challenge for you. And the second one is that you get to choose how you want to replicate that YugaByte cluster that is ultimately ingesting all this data. Do I want to keep it in parity with Vault? I can do that. Do I want to increase it in parity with Vault? Let's say that I'm concerned about possibly bursting a lot of this information, having a large amount of data there. I don't want to have to refactor sort of my YugaByte cluster in such a way that cluster architecture in such a way that I need to, someone needs to wake up at like the middle of the night and go deploy another cluster and then start replication. This is all stuff that you can choose depending upon what your security model is, what your resource model is, and ultimately what your needs are for different workflows. And I think this is what really is exciting. When we think about YugaByte and what they're doing with YugaByte DB and YugaByte Cloud, it really well matches what we're trying to do with Vault and a lot of other products, which is that we're trying to respond to a world where infrastructure is going to be dynamic, where things are going to change, where workflows, from a logical point of view may not change, but the impact of that workflow from a performance perspective, from a scalability perspective, from a resiliency against catastrophic failure perspective, needs to change. I might need to deploy new clusters. I might need to deploy, new instances upon which to communicate, new different types of secondary storage environments for tokenization, et cetera. This is very exciting to us. And I think what it really underscores is that we see YugaByte here at HashiCorp as a great example of an organization that is really on the same mission that we are, which is to satisfy the needs and requirements for a new generation of applications, handling some of the largest data security and data management workflows in the world. So thank you so much for your time. Really appreciate it. And yeah, as I said, looking forward to the rest of the summit and watching it with all of y'all, and happy to answer any Q&A that comes up as a result. Thank you again for your time and take care. Cheers.